All right, another Monday, another good class with Dr. Craig Wright. And what's going to cover today, Doctor?
So we're just going to keep extending what we've been talking about, like some of the issues of parallelization and other such things that you wanted to talk and discuss.
Mm-hmm.
All of which being how we start constructing like not only nodes in the sort of original mining sense, but specialized machines. So,
What is
um, so SPV, IP to IP, etc. So if you sort of remember, I've talked about a number of different aspects of Bitcoin that people don't think about anymore because Core have depreciated many of these. Um, and if you go back to the early days of Bitcoin that never got sort of implemented, and I got sort of talked down for being so silly with, which wasn't as in the right way I thought. Bitcoin was originally meant to be primarily IP to IP.
mm-hmm.
Now, the way that would work would be as a node, um, rather than all this uh, sort of BS right at the moment, where people go, "Oh, this is my address," and they publish it, which I've already said we can have methodologies for updating that. The sort of sending to a node or some other exchange was only a sort of backup option. So if I can't connect to this person, how do I send something to them and get a note where it is?
Mm-hmm.
How do I make sure that something's in there and then send to them? Now, there are two aspects of this. One, if we're doing SPV, we shouldn't need someone to crawl through and search everything on the blockchain,
Mm-hmm.
but which we'll come back to. Don't let me forget, but we'll go
Mm-hmm.
back into what we do there, and it's very, very simple. And the second part is IP to IP and what that actually means. Now, the majority of people are connected to the internet most of the time, and when they're not, they can set up um, agents, bots, machines, other such things.
Mm-hmm.
So, as an example, even in the old days, back with IRC, um, I don't know if you used IRC much.
Not much, just sometimes, just mostly for like developers. Seems like a old
Mhm.
school.
So, uh, yeah, so if you go back to the way it used to work, um, if you weren't running your own server, which ended up being part of what people did, if you had enough bandwidth and all sorts of other funky things. But even in the days before that, when most people weren't online all the time, UUCP copied emails, all that sort of fun stuff. You would want to construct like shell sort of functions so that um, if you had a channel or something or a nickname, people didn't take it and it could remain yours.
Mm-hmm.
So this is really the origin of bots. So
Hmm.
where people talk
Interesting.
about bots, the origin goes back to the IRC days where we would write little bits of C shell code just in C shell to do functions for us in IRC. So if you bought yourself a shell access to a Unix server somewhere, or had one at uni or corporation, you could then set something up that's online most of the time, so that when you come and go, you can keep your nicknames because there's no in the original IRC days there were no protections over things like nicknames or channels or anything.
Mm-hmm.
So anyone could jump in and
Mm.
be someone else and kick someone and all that sort of fun stuff.
Okay, seems a good place for Greg Maxwell to hang out somewhere. Okay.
Oh, I think that's where he
Gotcha.
grew up. That's his sort of origin. He never got out of Troll Kingdom. So
Yeah, it's like it's
um,
kind of like a full time doing this thing. Yeah, I don't understand. Yeah, but I think it's kind of yeah, it's kind of weird. But
I see he's been trolling you just as a little segue into something else.
yeah, so that's some it's almost like a elite club to join if he spends a lot all his time Sunday every. I don't know. I think he has some boss or something. Yeah, because like
Mm.
somebody just posted the article. It's like in within an hour or two, he just start attacking. It's like in the middle of Sunday. I don't know what he's up to, but seems he's not very busy these
Oh,
days. Yeah.
well, that's all he has for a life. So
Okay.
got to feel
So.
sorry for poor little Greggy. I mean, don't want to take away his only little hobbies and things.
Mhm,
All he has to do is say it's not Turing complete. Stop calling it
mhm,
Turing complete. There's no loops. I
mhm,
mean, actually, doesn't need to loop. Doesn't need to be the sort of anything but a finite string of characters. But we'll ignore poor little Greggy because he doesn't get that.
mhm. Yeah.
I mean,
Yeah.
after all,
We can
I
move.
mean, ignore what Turing says. Turing shouldn't
Hmm.
be able to decide how a Turing machine works.
Hmm. Yeah, that's pretty
Anyway,
much the definition.
um,
Yeah. Anyway, we can skip him. It's too much.
yeah. So, all right. So let's go into what we're talking about with IP to IP. So
Hmm.
not only can we set up machines, AWS servers, all sorts of fun things. I mean, plenty of machines online that you can pay for services. If you talk about uh, Facebook now, I mean, they're running stuff in the background for you to receive information 24 by 7. Well,
Hmm.
apart from when they have the odd outage, but that's not too often.
Hmm.
So when I was talking about IP to IP, I wasn't just trying to limit it to put in an IP address, which was the simple, pithy little explanation I had in the code. It was meant to be really anything. So if I want to connect to you online somehow, um, it should have been expanded out into domain names, into sort of certificate services to search and look for someone at different times. Um, I was hoping for things like mobile IP, but um, I hoped that when I built Bitcoin, I could, well, hand it over to people who wouldn't change the protocol, but would build all these alternative things. So rather than typing in the key and sending it to the nodes, um, other alternative structures could be built. So Paymail started doing some of this a while back. I
Hmm.
mean, the concept of putting information in DNS, like using a variety of techniques, including DNSSEC, has been around for a while, and that allows you to um, formulate methodologies to exchange. But if you think about it for a minute, um, think about the amount of extra privacy you get. And I said this in the early web pages and things. You get a lot more privacy communicating directly.
Hmm. Yes.
Let's say that I'm a merchant and you want to purchase something from me.
Hmm.
Now, if I'm sending things to just out to a node to be distributed in the peer-to-peer network of Bitcoin, um, if I'm if you're paying me and you're sending that information, think about what you now need, what you need to do to make sure that the purchase goes through.
Well, you mean information from you, like your Bitcoin address, right? That's for
Well,
sure.
so I need to now make that public. So apart from, I mean, ignoring the fact that I've talked about a number of ways that we can have that calculable, even if I'm offline,
Hmm.
um, how do I know what you want to buy?
Oh, you have to go through some other, I don't know, well, like an e-commerce website or your personal website. You have to, there's some
But
UI I
if
can.
but if there's that, why can't I send to that? So if you're online, so I can get that information. then I should be able to send directly to you, shouldn't I?
Yeah, you can if it's online. Yes.
Yes. So, I mean, the thing here, people haven't thought this through. What if I'm not online, but there needs to be other information?
Mm-hmm.
So we still need to, it's not just the buying and selling of baggies and trying to obscure that. In real commerce for real people, then if I want to buy um, some new socks, then I need to make sure that the customer, sorry, the merchant knows that I want to buy socks, what size, where they're getting delivered to, etc. Right?
And color red. Red. Anyway. Okay.
Yeah, I got those.
Okay. Yeah, of course.
But see, all of this needs to be done.
Mm-hmm.
So we need to make sure that we're exchanging information. So um, that can be just incorporated as a little bit of a hash. Um, it can be other template information, other things. Gavin and some others tried to actually build some of these concepts into Bitcoin in the early days. Um, didn't necessarily go as far as I'd like to see it, but um, there was some sort of creation and change.
Basically, to doing e-commerce as part of the Bitcoin itself, or is it something outside of Bitcoin, at least the node?
Mm. In the early days, I'd actually put stubs of different things like there was an e-commerce type
Mm-hmm.
merchant server in there and things like this. That didn't mean that it was meant to be that all nodes were
Mm-hmm.
everything,
Mm-hmm.
which
Doesn't
seems to
make
be
sense.
what people think.
Mm-hmm.
Yeah.
Mm-hmm.
So that just means I not really set up everything initially so that I had a difference between all the different types of nodes that would exist, which I did mention will happen. Now, but if we're communicating, I want to be able to exchange information about what I'm doing. So that would mean like you send me information, I send you back the price, you send me a purchase order, I send you an invoice, you pay me. All of that can be built into a protocol. Now, then you on your end uh, go through the transaction signing based on who you are. I know who you are. I maintain that information. It doesn't go private. It doesn't go publicly in the blockchain. It stays private, but it now gives me information that I can save in my database to know where to send your socks. Um, I can take the money, check whether it's been sent on the blockchain, send you socks. Now, if you think about it for a moment, one of the aspects of where people go wrong is, well, what happens if you try and cheat me and double spend?
I double sign. Uh-huh.
So you
Well,
want to, I mean, you've just sent me the money for the socks, but you're not sending it to the blockchain, you're sending it to me, and then I'm going to send it on.
mm-hmm. You mean how
So
to
before I
prevent?
do that, you,
Go ahead.
not even that.
Mm-hmm.
So you now go out there before I've sent it to the blockchain because I'm processing and it's not instantaneous and I couldn't care less. Um, and you double spend on me. And guess what? I don't send you any socks.
Yeah, yeah. It's it's uh, it's like I don't get paid. Why would I send socks? Especially it's not
Exactly.
digital goods, right? So it will take some time to.
Hmm.
I mean, even it's Amazon is fast, but it still takes some. I don't know, hours
Mm.
probably.
Yeah. So let's have an example of digital goods. Um, say I'm doing a movie
Mm-hmm.
and I allow you to watch the first 10 minutes.
Mm-hmm.
I could stop it after that, couldn't I?
Yeah, you can. Yeah, if I ever try to double spend, yeah.
And on top of that, if we're exchanging any information like IDs and things like that, because
Mhm.
it's a more than a very small transaction, then I can also report you and
Mhm.
have a criminal fraud case done against you. It's actually quite easy, as long as we move away from this code is law, big
Mhm.
bad government. You don't want to do any of that stuff, BS. Then we get into the scenario where it's incredibly simple to start um, defending and protecting all of this.
Mhm.
So um, now, where that can start coming into things, if we go back to that mentality of connections between parties, you and I connect, etc. Now, we can also start trying multiple options, uh, solving problems, doing incremental steps as we've been doing, but we can do many of those in parallel.
Okay. What do you mean? What are being parallelized? Parallelized.
Um, Different transaction options.
Okay.
So remember, we can have the input values um, change the sort of signed output value calculations, etc. We can also do that in such a way that without re-signing, we can even add extra information.
Like
Because remember,
malleability. Uh-huh.
yeah, malleability is one aspect, or even differences in transaction types, in which parts are signed versus not signed inputs
Mhm.
that are allowed to be added or changed, etc. And that allows us to have a wide variety of what we can do for payment options. So we can have a payment option that can have a range value where we're testing ranges of numbers. Um, um, as an example, in graph problems, uh, I'm yelling and swearing because a stupid fucking click problem that I've got keeps going out of range. Um,
Mhm.
because, well, fucking Python fucking sucks. Um,
Mhm. Mhm.
that's all I'm going. Well, probably won't be all I'm complaining, but my bitch about that is um, the machine keeps having errors because they run out of range problems because, well, uh, there's limits on what you want to do. And click searches in graphs are NP hard problems.
Mhm.
So, as you might guess, with NP hard problems, big problems get problematic quickly.
Yeah.
So, if you're trying to do too much at once on a machine, machines start complaining. If
Yeah.
that's a good way of putting it.
That's why it's called the MP hard, right? So.
Bloody stupid dead. And Python um, doesn't handle large things as well as C.
Mm. Okay.
I mean, it should, but it freaking doesn't. Um,
I mean, it's just something to quick to spin up something, but not best performant language.
ah,
So. It,
I know, but
mm.
yeah, I mean, and yeah, my bitch for the day is
Mm.
everyone keeps changing damn well things between versions. So if you
Mm-hmm.
have
Python
version,
3, Python
yeah.
3, Python 2. Okay.
Yes.
Mm.
So when you import stuff that you worked on before, you have to go around and change it all.
Mm-hmm.
I guess these days that's an old person problem because none of the young guys seem to have touched bloody Python 2 anymore. So
It's been a while. I think everybody's upgrading to 3. So.
I know, but that just means I have to go through and change everything. Anyway, now going back to the other issue, um, we can run things in parallel by sending multiple streams of information and data. Now, where we're trying problems, we can have it so that when there is a solution, only one of these work. But if we get a solution, I can now tell you I have a solution where I've been running things in parallel. You can be guaranteed to get your money if you solve it because I can lock things in. And then when I get the solved problem, you can return with, say, a hash that you've also incorporated that I don't know. Now, setting up this sort of function allows you to have lots of tests, for instance, that can run parallel. I can give you different options, and you can return the one that has been solved. And I can pay you when we get it. Otherwise, we both lock our money up and all that sort of fun stuff.
Yeah, you have been
I mean,
talking about this predicate and CUDA stuff. Is this how it's supposed to work?
that's one example. So, I mean, it also comes into when we're talking about SPV and the option to build nodes, which was the other part I was discussing. Now, rather than searching, we can run all this simultaneously with multiple transactions coming in, partial nodes in effect, rather than going out there and rebuilding the entire blockchain. If I'm a merchant and I'm getting transactions from you, and I'm checking whether these have been received, and I'm checking where they're going into, and I'm returning things, then I only need to build part of the Merkle tree structure. I can have only a partially populated binary tree.
Okay. Mostly the transactions you are interested in, right? Is that if involve you either sender or
Only, yeah,
receiver?
I mean, correct. I mean, effectively, only the ones I want to be interested in. And for other nodes to quickly check things, they can start pruning everything outside of the UTXO set. So have you worked with Cassandra or NoSQL or anything like this before?
And yeah, NoSQL, like a MongoDB, yeah.
Yeah, so if you think about that, that's basically just a large hash table.
Pretty much, yeah. Key value store, yeah.
Yeah, so what we can start doing is have a key value, which is every transaction's a hash. And we can match that against block IDs, which are hash. And now, if you think about that, that in itself is a hash. Rather than even having a standard 512-bit sort of SHA-512 hash structure, we could do something like a concatenated block and transaction hash.
Okay, I see.
So my comment on that, where people go, oh, concatenation's not secure, blah, blah, blah. Think about this for a moment. If I have a block hash and then I have a transaction ID, how many collisions do you expect to get in Bitcoin?
Negligible, 2 to the power of 256, maybe.
Yeah, fairly much rare. I mean, you should fairly much never get them. And even then, Bitcoin should have a problem if it sees the transaction ID twice. I mean, if that collision happens, then there's other problems. So.
Yeah, we talk about it too many times. Like if hash collides, there's a lot of things you have to worry about than this small issue. But so we can assume it's good.
Yeah, so we can make all sorts of funky structures. Now, and if we're doing like a sorted hash database type structure, then the block ID transaction ID is just as good as a SHA-512 hash, but quicker. 256 and 256 joint by concatenation are also fairly secure, as secure as we need to worry about. That gives us a unique value for every entry.
entry is uniquely identify each one transaction, right? And the block it is in.
Yeah. So that instantly allows us to map our UTXO set so that we have um, the block and the individual transaction. That can be mapped in NoSQL of various types so that we also incorporate like the Merkle path where it would be where we defined it for verification. That path can validate, of course, against the block ID, which is the beginning of the information there. So we can always check that the information that we have re the path is correct. We can then check the transaction information is correct because that will always hash against that path going back to the transaction ID. So it gives us, in that simple little structure, everything we need to maintain a UTXO set securely. Now, if you now start thinking about, we're talking about parallelizing things and making limited sets. This would be a merchant one holding all the UTXO set or even a UTXO quick check for miners. That will now allow us to have a very fast structure that we can hold over multiple machines. Because NoSQL, other such databases, of course, can be scaled parallel.
Yes.
So,
that's why UTXO works and count doesn't scale. Yeah. Like, horizontally scalable. Yeah.
So when we start thinking about this, it means this is where we can start doing our checks, starting to filter things as they come in parallel. So this value you can check there. If you now think about how we've structured a NoSQL database for this, parallelized servers, Xeon Phi is being killed off. Not sure what
really?
Intel's bringing in instead, but yeah, unfortunately, CUDA's still out there. It's going to be out there for a long time. I always liked Phi, but unfortunately, Intel have ceded that ground to NVIDIA and AMD. So, bastards.
So, a lot of complaining today. But anyway, so do you have some examples? You just talk about the key structure, right? You concatenate the block hash with a transaction ID, also the hash. So what will be some of the value you want to associate with it? Start there. Other than, for example, transaction, serialized transaction, probably there. What other examples?
So we're talking about doing larger scale SPV, not just user SPV. Now,
What's
imagine
the difference?
if you users don't generally run their own NoSQL servers or equivalent. Now, imagine though that we're a large merchant and we're offering a service and we have a limited subset of the blockchain. I've talked about overlay networks and creating other things, for instance. Not only can we build a specialized transaction structure that is secured by being inside the blockchain and then linked, but we can now build all sorts of other substructures, whether that's something as simple as tokenization services, central bank digital currencies, etc. But we can also then build that even further. We can have substructures in there and sort of grouped information and state that now a secondary machine processes and gives information for. So
kind of like layers, is it?
Yes.
Okay.
Yeah. So other forms of consensus database, other forms of competing system, other forms of protocol built in the same way as Bitcoin, or single company systems, or all sorts of funky things.
Mm.
So, but what I'm trying to start you to think about is this can form the basis of not only microservices like we talked about last week with like small server type applets, going even further than some of the concepts of like web services. Like people have already made Bitcoin web services, and they've already stored files, and they've made simple data structures, etc. But on top of that, as an example, there are database structures that can be coded even inside web pages. In Slack, I've posted a few things about that before, where people have built static web pages that incorporate databases. And they can make calls to other information, which could also be stored in, well, basically in blockchain or ancillary server levels that can go out and pull information and return it. So I can then do my sorts on all of this information and send multiple transactions to you, pull information from you, update information, have a rich replacement of web experience.
Okay.
So I guess I'm still trying to get people to think a bit bigger. Not,
Always, yeah, like a block size.
yeah. So not just, yeah, that's pitiful small, but I want you to start thinking beyond that and going into how do we build business applications. Now, one of my favorite ones is always logistics, EDI, plumbing, as always. The boring things that most people don't care about. But how do we, I mean, micropayments is the other one, but with ads, that's actually a harder sell than it should have been 10 years ago. Ironically, 10 years ago, it was an easier sell if people didn't move into all the crap they moved into, but now it's a harder sell. It'll take time. But how we get that value without the level of volatility is use. And as an example, logistics. You look at network problems, tracking problems. So why do I play with, apart from Bitcoin's a graph network itself, so are logistics problems. So looking at solving those. I mean, we've talked about traveling salesmen, but there are other problems within networks. Nearest neighbor problems. There are sort of optimal path problems, not only the traveling salesman one. Click problems. All of which we can pay people for better solutions, pay people for solving, have ways of optimizing. But equally, while we're doing that, we can now weight them and have payments simultaneously. So we can have other ways of solving some of these. Now, how might I solve a logistics problem that isn't a computer problem? I mean, you'll use a computer for it, but it's not actually a computer-based solve. So give me an example.
Logistic, I mean, not, you mean logistic problem, but not a computer problem?
Yeah.
Oh,
Yeah.
that like counts. Like, how do you identify some let's say watch is it's authentic, right? Or any bags, is it Louis Vuitton or not? Just random thought.
Yeah. So we can do that by incorporating information and having it on the blockchain rather than this NFTs for Bebo or Beeble or whatever the hell he is. Um, the bag could have its own unique marker. So I mentioned this a number of years ago and had gasps of horror from some people who had obviously probably fake bags because you mentioned this and how all your friends could tell whether it's real or not, and people go, "You don't want to do that." Of course I do.
Yeah, it's not
um,
everybody wants to do that kind of thing. Yeah, if you're like buying like a, I don't know, $100 supposedly luxury bag, you don't want your friends to find out. Anyway.
exactly. So if you want your real Hermie versus the fake Hermie, or whatever brands are out there other than that, I don't know, for women, Jimmy Choos or um, ugly other shoes, then you could tell. I have absolutely, apart from Hermie, who do other things, I have no idea about other brands of women's bag. Um,
Okay.
ask my daughter. My daughter will be sure to tell you, but I wouldn't. But that's a type of problem that can be solved. I mean, that information can be out there and checked. But you can have just a little is valid check. Then when people want to sell it, that can be the probity of the transaction, the sale can be put out. But equally, another thing would be auctions. Now, think about how a number of different protocols have done for where there is a limited supply over the web. You can have an auction or reverse auction. If there are a number of drivers and they're sitting around idle, then they can lower their cost. If
Like a
there's people who are busy, they raise it.
like a Uber
So,
internally, they're using this kind of algorithm.
um,
I bet. How is
yeah.
this
So,
related to Bitcoin? For example, this kind of auction.
yes, definitely. Yeah, definitely. This can all be built in script.
Okay.
Now, if I'm not sending to the blockchain, then start to think about the differences here. So, what I can do is for my auction, I can have a transaction that joins other transactions. Remember, we can construct things where we can add inputs.
Yeah, like anyone can pay.
Mm-hmm. Now, what I can do is I can have a transaction where I pay to myself, but I allow other inputs, and the option now is to close the transaction afterwards. So I put out my auction request, which includes my input transaction, which I can even lock by having other information you don't know, etc., etc. Um, I could have a hash puzzle in there that I know, and that allows it to be spendable, for instance. But you can't do anything with it until you have that final bit of information. Um, Now, you can add your transaction, and you can do it in such a way that it is linked to mine.
Okay.
Um, there are funky things we can do that we've used in our puzzles where we can actually utilize the information in keys, etc., in signatures to validate different inputs. I'm not going to talk through it, but if you remember some of the things in the R puzzle, we're actually using information that theoretically everyone tells me I'm not supposed to be able to use, but obviously I can. So I can secure a transaction, but now if you and five other people are bidding for this, how do you know I don't take all of your money?
Um, you, you can require something. Yeah, only I everybody has to agree before it's spent.
But do I want the people I'm competing with in an auction to agree?
No, that you are competing. So,
Yeah. So,
so
as an example, say you and the five others give me a transaction, but it incorporates a input from me.
you are also part of the competition, or you are like some I don't know,
No,
Uber
I'm the one
server or some.
who's I'm the one who wants you to bid for the service,
Okay.
or you're making an offer to me.
Mm-hmm. So let's say just in a Uber example, right? So you let's say I'm you are the driver and I'm like you have
Hmm.
five passengers who wants to go to
Hmm.
some places, but you are
Yep.
just one guy, right? So
And
we'll submit bid to
yep,
you.
I, I've given you my token. You now add your transaction to it, and I've got five of those to choose from.
Mm-hmm.
I In this situation, I can even make the decision not to choose the highest bid because I don't want to drive to um, York. I
Mm-hmm.
don't know if you know. I mean, London to
Cam
York.
okay. I've
I
been
mean,
to Cambridge. That's almost like 1.5
York's way
hours.
further. Yeah,
Way further. Okay.
York's like several hours. So,
Okay. Okay.
um, so you know where Oregon is?
Mm-hmm.
Do you want to drive up there?
No, that's like 7 hours to the border. So
Yeah, there you go. So, um, as an Uber driver, you have an option here. One of the things is giving a chunk of money, but they want to go to Oregon from your location, and the other ones are all competing. Now, you can still discard that. Now, what you do is you send out, like I've selected your bid. I let you know, I update your information, and I send it to the blockchain. Now, when I do that, it invalidates all the others. If all of them have used my input and their own, I don't really care because I've paid myself, say, one sat, and it's going back to myself.
mm-hmm.
I mean, I got my one sat back. Yippee.
Mm-hmm.
But you see now that one sat has
Mm-hmm.
locked all of the other options.
Okay. So it's not that one side is not it's almost like a marker. It doesn't function any other.
Yeah.
It's not going to pay minor
Yeah.
fee. It's going to pay
No, I
yourself.
mean,
It's like a
exactly.
marker. Okay.
So
Tag
I've given you a transaction stub where I'm saying I'm paying my one sat
to
to
yourself.
myself.
To yourself. Okay.
So you can't steal my one sat.
Mm-hmm.
I mean, you can try, but I don't think you're going to go into any effort to steal my one sat or try and stop it being spent because, well, I've also given it to other people. But now by adding your transaction and then signing the lot of it, uh, and remember, you can sign the entire transaction and complete it so that uh, this is what you're giving me. You hand that back, and it's a valid transaction if my one sat transaction hasn't been spent.
Mm-hmm. Of course.
And then, but the difference is if I spend that one sat transaction by choosing one of the others,
Oh,
your
okay. It's gone.
transaction is,
Mm-hmm.
yeah. Now, equally, I can keep records of all the bidders.
Yeah, you can. Mm-hmm. It's just some
I
small
can.
transactions. Mm-hmm.
Hmm. And here's the thing, that's not on the blockchain.
No, because eventually at most one of them can be valid, right? Because it's all linked,
Yeah.
spending the same
Mhm.
UTXO, you cannot double spend.
Yep. So as a merchant or server company or something like this, I can still collect information and have knowledge about my customer base that I can use to data mine and find other information on. And the thing is, it can be private because I can act in a way that I'm not going to share it with you guys. I know your transaction, but you don't know who else has bid, do you?
No,
Unless I want to tell you.
no.
So
Mm-hmm.
see, see how building things off the blockchain gives you a whole lot of extra options while still maintaining all of the security of Bitcoin.
Mm-hmm.
I mean, can you tell me what a vulnerability in that protocol would be?
Uh, using you mean the auction protocol you just mentioned?
Yeah. Hmm.
I don't see any. I mean, so far I haven't found any because I mean, if you don't use Bitcoin, probably you if I give you my offer, and
Hmm.
also somebody else give you can take both offers, right? But you only drive one
Mm.
trip, you earn twice. So probably you just cheated the other guy. So
Yeah. But I mean, if I've locked it, I can't take two offers.
no. Hmm. Yeah.
So I
Here's
can't.
you can. But if you have let's say two passengers,
Mm.
they all give you but how they cannot verify you are locking using the same input, right? You they don't
Mm.
know each
Yeah, but
other's
if I have
offer. Is that what
no,
you're
not
saying?
necessarily. But then if I'm doing two passengers who are no, I was originally doing an auction type thing where I choose one or the other,
Hmm.
uh, or even I can give different tokens as well. So I could give a token for first trip, second trip, third trip, and each person could even bid on that, going, um, if I take this, these are the time frames that can be calculated, and the first trip options, the second trip options, and the person could wait and have a cheaper thing, but be picked up in different areas. So you can actually build a whole lot of. Um, um, I'll be over this area because I'm already doing these two trips. So I will put out this token, and I can take you if you're pre-booked for this time, or if you're willing to wait. And
Hmm.
then you can decide whether you want that.
Hmm.
All these funky
Yeah.
things you can start building and paying for.
Hmm. Okay, just
So,
play devil's advocate. How is this different from the Uber? Now you can already share ride, right? So if you go to Oregon, I can say I can pick up some guy in San Francisco city. I go pick up some guy from Cambridge, right? If I'm going to York from London,
hmm.
it's already they already have this
so,
feature, right? How is this better?
so right now, I can go to Uber, and Uber can take all my information, and I can trust Uber,
Mm.
even though Uber's sending out other drivers. What if I could now remove Uber?
Oh, I see. Okay.
What if
Hmm.
every driver could send things out on an open protocol and anyone could make an interface for this? And
Hmm.
Uber could make an interface going, I'm prettier than everyone else.
I see. Okay.
And I have better image sharing and I have this stuff. But anyone could send and exchange the same protocols.
Hmm.
And any driver could advertise themselves in different ways. And anyone could have different rating systems. And other people could differentiate by saying, I have a rating system on my drivers. So all the drivers on my site are vetted um, because they haven't ever had a car crash or I don't know.
Hmm.
They have clean driver's
Clean cars.
licenses.
Oh yeah, they don't drive like crazy in India or anything. Anyway.
Yeah, exactly.
Okay.
Um, but equally, all that information could be shared across multiple platforms. So now it also means that as the driver, at the end of the day, you and I are directly negotiating.
Hmm.
Now, if there are platform fees because I'm
Hmm.
using an aggregation service and a reputation service, remember, I can equally build that in. So the reputation service could sit there and say, I want to, as a part of the service, get paid X for every sort of option um, that you get, that you successfully get.
Hmm.
Now, in that, what I do is I put out one, the token I have, and two, the token they have, and I join those. and the token for them is a payment token from me as well. So I pay the reputation company that I want to manage my reputation as a driver and to promote myself and say how wonderful I am, um, this amount. And then I send it out to all you people bidding for me, or to have my service. And then off we go.
Mm-hmm. Okay. Do you
And
see all the
equally, I'm sorry, equally, I was just going to say, it can go the other way around as well, where you're searching for a particular type of car, etc.
Mm. So is that how you see like all this going to different industries going to play out? For example, we just talked about this. I think like blockchain people want to, they even say there's a Uber without Uber,
Mm,
that's or even say Facebook without Facebook. It's like a
yeah.
social network protocol, but not a company. It's like yeah, people use this and like a
Hmm.
GPS. I think at the beginning, that's what I heard. When they commercialize
Mm,
GPS system, they have a choice whether to set up a
hmm.
company, do this thing, or you can be open
Mm,
protocol like a GPS now. Everybody can use, you can build it, you can
yeah.
use location service. Is that how
Hmm.
you see a lot of
I
like a
would be
Bitcoin?
much happier if we starting. I would be a lot happier with a lot more things being set up that way where they're open protocol. People can start competing, for the better code, the better service, the better options, but they can actually compete.
Mhm,
So, I mean, potentially you can even have aggregation services that, maybe instead of Uber, you sign up for aggregation service,
mhm,
and it only it can advertise the types of drivers that it takes. And if you want to migrate to different ones, well, drivers can be across multiple platforms.
mhm,
Um, right now, if you're looking at, say, Lyft versus Uber,
mhm,
then, I mean, in theory, you could have both apps and
mhm,
do that sort of silliness. But what if you just had, someone could have an aggregation mashup app where they put different things together and different apps, even if you no longer like this one because there's a new one, you just move across and there's no cost to you, the consumer. I know
mhm,
that isn't popular to anyone in Silicon Valley because
mhm.
their
The
whole model is
auto
how do we
blocking,
capture?
how do you make it as sticky as possible? Because if you're Uber
Yeah,
user, they probably never want you to go to some any other Lyft or anything. But probably good for the company,
yeah,
but not for the
um,
always for the customer or users or even Facebook there or Twitter, anything you pretty much lock up. You can, I mean, theoretically, you can download your user data if you
hmm,
want to leave, but nobody recognizes it, right? So that's almost, if you drop,
no.
it's that, right?
So I mean, yeah, that's the interesting thing. If we had a standard data format, and sort of an ontology that was public, then in theory you could have Twitter, versus, um, I don't know, shitter, um,
Hmm. Hmm.
and you just I mean, log in and there's your data.
Hmm. The same as kind of like own data, but also not only applies to social network, but also to all kinds of other
Hmm.
verticals
Yep.
like transportation or even
Yep.
commute or
Hmm.
I don't know, like even
Yeah.
reviews, right?
Yeah.
Online review, true review. Okay.
Hmm.
And because it's
Yep.
everything is on chain, so you can,
And
it's very interoperable. You can get some reputation service. You can
mm,
even show your some, let's say your qualification, right? You're saying, oh, I'm a, I
mm,
don't know, doctor, or yeah, it seems like all this can combine together. It's kind of big, but that's
mm,
how you, that's how you see it. That's going to evolve. Like different industries, they can be disrupted by so-called decentralizing,
mm.
becoming practical.
Yeah.
Is
I
that how
mean,
you?
um, yes, I sort of, hate some of the use of the word. I mean, the
Hmm.
reality,
Yeah,
though,
it's
is, most people don't realize what decentralized means. I keep pointing out that Facebook is decentralized. It has lots of shareholders,
mm-hmm.
but
Yeah,
Facebook makes decisions based on, sort of a
one
few
guy.
people like Mark
Hmm.
Zuckerberg who choose. So you can say, oh, it's decentralized. They've got employees and they've got shareholders, but so what? Like Ethereum and proof of stake, if Vitalik owns and his foundation own the majority of sort of coins that can be locked up, then they always choose what happens to the system. They just want to run around going, it's not actually a security because we say it's not. Please, Mr. SEC, don't treat us as a security. We don't have any
Dividend.
dividends, which makes us really different from companies like Facebook and Google who don't have dividends.
Yeah,
We
we're
promise
being.
not to have dividends apart from, yeah. So, um, so, but going back to the other options, start to see now how we can build some other extensions. Like I can even put out a tender and say these are the options, and it can be private, closed, and you don't know what the other tender is, but equally you can validate. So if you put out a tender and I submit $100,000 and it's a government tender and it's whoever has the best price. It's one of those, right? I don't know who else is bidding, but I can now guarantee that I can complain and have evidence in court if I have the highest bid, even though I don't know who else is bidding. I can check that and go, I didn't win this, but I bid this. How do you think that might happen?
Oh, I think that's you always talk about this, especially the COVID thing. It's like a government now pretty much give up all this like a transparent bidding. You just have some like a crony thing going on there. It's like in California,
Yeah,
the governor
but
just give out some contract to his like a brother's company to buy some masks.
so
Yeah.
here's something for you to think about. The auction type thing I just said, where I give you a token. Now, if I'm giving a shared token across multiple parties, they can now look at that on the blockchain when it goes up there, right?
Yeah.
So they can see, I didn't win, but it's been spent. Someone else
Oh,
won.
okay. Okay. Then it's already settled. You
So
can see
I
there.
can then look at that.
You have
Now,
proof.
if I've got a signed transaction, I can save the hash of that transaction on chain. That now proves that it existed at that time. I can even have sort of proof from you that you received it that I could hash and put up there as well. All sorts of funky things if I want to be really sort of careful. I can send you the thing. You can send me a receipt back. Blah blah blah. All of these sort of funky things. Won't go into all of that. But the simple thing here is now I can. I have evidence, and it's not all this. Oh, it's a smart contract bullshit, and it has to be automated. No, what I now have is I have evidence that I can use in a court case to go, I put this bid in for the tender. I put in $110,000. It was taken for $100,000. There's a problem.
And you have the proof because
That's all I need to do.
you
I have
signed it.
proof. So it's not all this anonymous crap. It has to be what it actually is in the real world.
Yeah, which we living. So I don't know some other
So
people that seems they are in their own world. Anyway.
So anyway, that's
Okay.
probably enough for tonight.
That's good enough.
Next week's going to be the last one before CoinGeek,
Yeah.
because, well, there's CoinGeek. So I will see you then.
Okay. See you next week. Okay. Enjoy your evening.
All right.
Okay.
Catch you later. You too.
Okay.
Bye.
Catch you. Bye.